Okay, so what we're looking at today, we're looking at relations, and really more importantly than that, it'll kind of lead us up to this one. We're going to talk about functions. Okay, and first thing that we've got to kind of back up to, and this is going, and again, part of this first part is kind of backing up for a few things here. But a relation, when they talk about it in the math sense, it's just a set of ordered pairs. Now, could be two ordered pairs, could be five, could be seven. Just it's just a bunch of ordered pairs, no matter what we're doing for this. And for the relation, they may give it to you in a list. They may give it to you like in a graph and say, here's a graph of a relation, and they'll talk about that part. So they can show this thing a bunch of different ways. But the big thing we've got to make sure that we've got for this part of it. Here's something that's kind of new that we'll talk about this part. This part we'll talk about all year long. So we'll talk about it today, but we'll talk about it basically nonstop all throughout the year. Domain is your x values, or if we're talking about different equations, doing some stuff, that's the input. That's what you're going to plug into an equation or a function as you go into this thing. The range is your y values, which is your output. And we normally think about that as being the answers as we're talking about something. Okay. And what makes a function a function? Is that functions cannot have repeated x values. That a function, if you want to kind of think about it in this way, I always like to think about it. It's like a vending machine. That if you push a button, um, if you've got repeated x values for this one, so if you plug in, you know, some button on this thing, you might get a Coke. You might also get a Diet Dr Pepper or something like that. So basically, it's going to take you off in two different directions for this thing. So basically, functions are saying, all right, if you give me one number to plug in to this particular function, I can tell you every single time what the answer is going to be. That it's never going to change for this thing. So it's always something that you can just repeat. It's never going to change when it goes through this thing. Um, all right. So what we're going to do is basically this. We're going to list. Give you some examples here. We're going to list the domain and range. And then tell if the relation is a function. Okay, and for the first example here, I'm just going to give you a bunch of ordered pairs for this thing. Okay, so 4 points: 210, 38, 46, 55. All right, and again, easy thing we're going to try to kind of get through this one, just make sure everybody's okay with it. When we talk about domain and range, again, domain is your x values, and if we're doing these on Math Excel, if you're filling in the blank on this one, usually you got to fill in the blank. You can just go back and kind of put the answers in there. What's that? Usually they'll give you some kind of bracket that's outside this one. So domain is just your x values. It's 2, it's 3, it's 4, and it's 5. So then you just list off those numbers. Okay. It doesn't necessarily have to be in order. As long as you've got the numbers listed, that's really all that matters. Whether you put 2, 3, 4, 5, or 5, 4, 3, 2, or 3, 2, 4, 5, it doesn't matter. As long as they're all listed, that's the main thing that's there. Okay. And in your range, that's just your y values. It's 10, it's 8, it's 6, and it's 5. Okay, again, is it a function? That's where we're going to use our x values here. That's where the domain comes in to help us out with this thing. So in this case, if we look at our domain that's here, there's no repeated values. So is this thing a function? Yeah, it's going to be a function. So whenever you're looking at what a function is or not when it goes through these, you really don't even care about the range. I mean, the answer, I mean, yeah, we need some stuff to go with it, but the domain is going to determine what your function is. So you can basically, once you list off your domain, you can use that to help you figure out function-wise what this thing's going to do. All right, so for example 2, same thing. Let's go 2, 4, 3, 5, 4, 6, and then 2, -7. Okay, so for your domain, when you start to list those off, that's 2, 3, 4, and then there's that extra 2, right? So you got 2, 3, and 4. And if something repeats, like in this case, you don't have to write it down twice because 2 is already there. So that's representing that 2. It's also representing that 2. And again, as soon as you do that part of it, that's where you can answer it. If this thing is a function or not. Well, in this case, it's going to be no because the 2 repeats. Okay, and again, that's really all you're looking for. You just look through your x values. If any of the x values repeat, you know, this is your Dr. Pepper and that's your Diet Grape. If you're going through the vending machine, two things you don't want. Now they're still going to have you go ahead and list your range. So we've got 4, 5, 6, and -7. So we can go 4, 5, 6, -7. Okay, so there's where they'll give it to you as a list. Again, sometimes though, instead of listing out the points like this, they'll give you a graph with some points on it, and then basically at that point, you still want to just go back and kind of write down what those order pairs are, so that you can go back and pull the numbers from that one. I was going to give you a graph, but sometimes it just kind of takes a bit. I guess we can go ahead and do that. All right, so for example 3, we'll actually give you some on the graph here. Actually, before I do that, let me get you some graph paper so you can see it. If you don't have graph paper, you can just kind of watch and see. Okay, so there's our x-y axis. Let's go with this point. So they'll give you something like this where you got a point here, maybe a point here. And something like that. Okay, and it'll be the exact same question for this one. List what the domain is. We'll list what the range is, and we'll figure out if this thing is a function or not. Okay, so if they give you a problem like this, you're still basically going to do the same thing. You still need to go back and write down what the order pairs are. In this case, you've got -2, 1, 2, 3, 4. This point is at 0, 1, 2, 3, 4, 5. This point is at 2, 2. And this point would be at 4, -2. Okay, and again, if you've got the points kind of written out, you can see, all right, there are no repeats here. So function or not, yeah, we know this thing is going to be a function because nothing repeats. Our x values are there, negative 2, 0, 2, 4. And then our y values are at 4, 5, 2, and negative 2. Okay, and again, order does not matter as you list out the domain and range. The main thing is that you have the domain and range listed for those problems, and that's all you got to do. Okay, so they give it to you in a list. They give it to you in a graph. Which again, if you've got a graph, you can pretty much turn around and make it into a list that you've got your relation there. And the other thing they do, they may also call. Sometimes they call this a mapping. Doesn't really look like a map, but they'll do basically the same thing here. And for a problem like this, they're probably not even going to ask you to list the domain and range because they're going to give it to you. The question in this case is they're going to ask you, okay, is this thing a function or not? So maybe the domain is 10, 20, 30. Your range is 0, 5, 10. And again, the question they're going to ask in this case is this mapping a function or not? Now, before you do that, what they're going to have is something like this. That they will have you some arrows drawn. So you know that this 10 goes with this 10. The 20 will go with the 0. 30 will go with 10. And then 20 will go with 5. Okay. And it still comes down to that same thing. As long as there's only there's no repeats in this. That's okay. So if you look at this one, this point would be at 10, 10. This point is at 20, 0, but this point also goes to 20 and 5. So function or not for this thing, we would say no, because there's two x values. The x value of 20 basically it has two arrows drawn from it. That again, if you were to write that one out, that would basically be the order pair at 20, 0. This order pair would be 20, comma 5. So you're still got the same problem in that case that you've got two arrows coming from the same point. So there's two different values it could be. Okay, and then one more mapping just to kind of give you a visual for what it looks like here. Again, instead of being domain and range, sometimes they'll put X and Y. Okay, and then same question. If this is the mapping they give to you, is this thing a function or not? Okay. Again, you've only got one arrow coming from each X value. Even though they're all pointed to the same value, that's fine. So is this thing a function or not? Yeah. So it's like when you watch the commercials and they're like it's a Coke commercial or Dr. Pepper commercial or a Mountain Dew commercial, whatever it is, and like you see the vending machine and like every button on there is a Mountain Dew button. You don't have a choice. That no matter what you do, you're always going to get the same thing, and that's okay because every button is going to point to you're getting a Mountain Dew or you're getting a Dr. Pepper or a Coke or whatever. So, and that's okay because again, it's all about your X value. As long as there's only one value coming from each X, even if they all point to the same thing, that's still fine. Okay. Now, one thing you can do, and this will we'll back up for a minute. If you do have a graph that they give to you, whether it's a bunch of points like this, sometimes instead of giving you a graph like this where it's individual points, they may actually give it to you so that you've got a line connected, so it's something like that. But there's actually easier, instead of having to write down all the different values, there's an actually easier way to go back and do this if you have graphs. That we're going to use a vertical line test for graphs. Okay. And with that one, you don't have to actually do anything. This is one of those parts where you can just look at a graph and kind of see what's going on. And basically is this. If any vertical line drawn through the graph intersects the graph two or more times, then it's not a function. So, and again, you only need one. If there's 10 of them, that does the same thing. But if you draw any vertical line, if you can find one vertical line that you can draw through the graph, and it hits the graph two or more times, it's not a function as you go through that thing. Now, if you want to be the optimist side, if every vertical line drawn through the graph intersects the graph only once, then it is a function. Sometimes you have to kind of take the pessimist side, but you can make an optimist side if you want to. So if you flip that around again, any vertical line drawn through the graph intersects the graph only once, then it is a function. Just depends on how you want to go with it. So what you'll do basically is this: is you'll be given a graph, and they'll say, "Is that graph a function?" Okay, and then you just go through and see how many just start drawing vertical lines through it. If I draw a vertical line here, only hits it one time, so that one's good. Draw a vertical line here, it's only going to hit it one time. Draw a vertical line over here, only going to hit it one time. So they ask you, is this graph a function or not? Yeah, we're good. Okay, now the obvious part. We turn that graph sideways. All right, and pretty much every vertical line now we draw through this thing is going to hit the graph two more times. So if you do that, you hit the graph here, and then you hit it there. So you're hitting it twice. You hit it here and you hit it here. So they ask you for that one, is it going to be a function? No, it's not going to be. Question. All right, now again, here's where you can kind of think about this one. If we drew a XY axis through this thing, you don't have to. Just I'm going to do this just to give you a visual of what's going on here. If you looked at these 2 points, this point is at 1, 2. This point is at 1, -1. So what those two things got in common? Yeah, got the same x values, right? So it could be one value could give you 2. The one value could also give you -1. So all that, when you draw that vertical line, it's basically that visual check for looking for the x values to be the same. Because again, if we go back to what we were doing with the graphs of the day, if we graph this line right here, it would be x equals 1. So that's telling you all the points on there that's that way. So it's kind of, again, tying in the graphs we were doing a little bit the other day, but now it's tying it in, with the vertical line to figure out if it's a function or not. So, okay, now the ones you got to be a little bit careful of. They'll give you a couple of graphs that sometimes might look a little funky. So instead of just a straight, parabola or hyperbola or something like that, they may give you a line that's like this. Okay, so over here, you're good because you got your vertical line going this way. You're only going to hit it one time. Over here, you're good. You're only going to hit it one time. It's this one that's here that if you draw this vertical line, that gets to be the issue, right? Okay. But if you remember, kind of going back to some of the graphs we were doing the other day, open circle means you don't get to use that point. You get really close to it. Solid circle means you get to use that point. So even though these two things are on top of each other, you don't use this point, but you do get to use this point. So they ask you, is this thing a graph of function? Then yeah, it would be. For this to be a no, that'd have to be solid. So if that was solid like that, then it would be a no graph because then those 2 points are included. But if that point is open and that point's closed, then again, you're only using this point, you're not using that point, so then you're okay. Okay, so vertical line test. It's especially for graphs, really quick, really handy, easy tool. Just draw a line through it. If you can make the vertical line hit it twice, it's not a function. As long as every vertical line on it only hits it one time, then you're good to go. Okay, so there's kind of everything leading up to that part of it. The last little thing we need to look at is function notation because we keep talking about functions, and we actually need to look at the function notation here. So what does a function look like when we're looking for one? And y'all probably have seen this before. Maybe just I think we even had a problem the other day where we had one that had something like this in it. Okay, so the big thing with function notation is that with equations and working through those, instead of having y equals something, in this case they're going to take the y and replace it with f of x. And again, when you see this f parentheses x, you read it as f of x, not f times x. So there's not any time with anything that we're going to do where we're going to have f with one variable and x with one variable. So, anytime you see this symbolism from now forward, basically through pre-cal, for calc, anything else you do, you can always think that they're talking about functions. So this is always going to be f of x. You will never read this for your math going forward as f times x as you go through those. Okay, so here's the big thing that you're going to look at when you go through these. So just like when we were graphing some of these problems the other day where we had like y equals 2x plus 3, and you had to graph this one, that if they want to just bump this thing up a notch and say, okay, well, this is not just an equation, this thing is a function. So instead of having y equals, now you're just going to have f of x equals. Okay, these graphs look exactly the same way. They're going to function the same way. They're going to operate the same way. Just the only difference is this an equation. If they take the y out and replace it with f of x, then it's f of x equals. And if they ever ask you to take it back to an equation, function or not, you can always just take the f of x out and replace it with a y, and then you're good to go there. Okay, now, and the big thing that they kind of have you do with this one is that um, that with these problems, the big thing that you're going to have to kind of do is that instead of basically this, that you're having directions that say evaluate that equation, y equals 2x plus 3. when x equals 7. Because that's kind of the old way of working with it. They would give you an equation, tell you, here's the equation. We want you to evaluate. We want you to plug in x equals 7. Tell us what the answer is in this case. Okay, so for functions, we'll ask, they'll give you, or we'll state, kind of the same thing. F of x equals 2x plus 3. And they're just going to say find f of 7. So kind of a mathematical standpoint, it's a little bit faster way of finding answers. Still working through doing some of the same things and going through some parts on this one. But again, it should just be now that they don't have to say, here's this equation, y equals 2x plus 3, evaluate when x equals 7. Now they're just going to say, you're given f of x equals 2x plus 3, find f of 7. Okay. And when you're working these out, when you're evaluating these functions and giving you these values, the best thing I can tell you to do to work through these is that when they give you a problem like this, write down what that equation, write down the function. And then right underneath it, like we've got it here, go ahead and write down the number that they give to you to tell you to evaluate. And then basically what you're seeing is that everywhere you have an x, you take out the x and you replace it with a 7. So over here, you take out the x and you replace it with a 7. And then everything else is just you working around that problem. It's 2 times 7 for 14, plus 3 would be 17. Okay, I know right now somebody's thinking, well, what about the left-hand side? You don't do anything to the left side. Because again, this is basically your y equals. So this is basically saying, all right, for this equation, when you plug in 7, you get the answer of 17. So technically on this one, you would have f of 7 equals 17. If you were writing that as an ordered pair, that would be your ordered pair answer if you're going through this thing. But probably most time in Math Excel, what you're going to see is they'll give you this function in the question, and then the answer is just going to be this, and there'll just be a box here, and you just go back and type in that number. All right, so then a couple more things, then we'll wrap this thing up. Okay, so we're going to give you this one equation, f of x equals negative x squared plus 3x minus 2. And we're going to have an A and B part. Now, part A, you're going to find f of negative 7. Okay, and from this point forward, anytime you're plugging in values, and especially with negative numbers, whenever you plug in a negative number, notice how the number's in parentheses. Make sure when you plug in this number over here that it's in parentheses. Same thing back here. Even though it was a positive 7, it was still in parentheses. And if you do that, there's about a 99% chance that you're going to get the right answer when you go through these. If you don't put the parentheses, that percentage probably drops to about 49%. Okay, so whenever you're plugging in these values, make sure again that the negative 7 is always in parentheses. So it's a negative 7 that's there. That x is also a negative 7. And then everything else that they give to you has to go on the outside. This negative has to go on the outside. That squared has to go on the outside. Plus 3 is on the outside. The minus 2 on the outside. And I've seen, I don't know how many people miss that because they don't put parentheses around the problem. And because, a lot of times they'll work through and like, what do we do? What's the steps in this? And I'm like, okay, go back and put parentheses around that number. That should take care of about 99% of the questions that you have. Because from there, before you do the minus the negative, you've got to do negative 7 squared to make that 49. The minus that's in front is going to stay out there regardless of what we're going to do back there. Okay, you've got 3 times negative 7, which is negative 21, minus 2. So if we do negative 49 minus 21, that is negative 70 minus 2. So that would be a negative 72. Okay, now here's the other thing. I know some teachers don't like to do this, but I kind of like to do this. Here's where you can use your calculators too. Now, the thing you got to be careful of when you're using calculators here is that, especially with the negative numbers, you have to use your parentheses. If you don't, you will not get the correct answer because of the way that the problems are going to read these when you plug it in. So if we take that exact same number we got there and we're going to plug it back in our calculator, we're going to do minus parentheses negative 7 squared plus 3 times negative 7 minus 2. We get negative 72. Okay, and if you, and I'll just kind of show you real quick, if you didn't use your parentheses, if you had minus negative 7 squared plus 3 times negative 7 minus 2, you're going to get 26. So that's one of those things where, again, parentheses make a huge difference when you plug these numbers in, because if you don't plug in the parentheses, it reads this minus negative 7, and it says, oh, I've got a minus negative. I'm going to make that a positive. So I'm just going to make that a positive, and I'm going to square that positive and make it a positive 7 squared, which is 49. This answer, if you look at it back here, with parentheses around it, if you go way back to, the old math things, if it's negative 7 squared, that's a minus times a negative 7 times a negative 7. Oh, can't see that. My bad. So if you've got minus negative 7 squared, basically it's this thing. So you've got 1, 2, 3 negatives. That answer has to be a negative. Where when you write it this way, without parentheses, there's only 2 negatives. It makes it a positive. Okay, so that's where, again, parentheses make a huge difference on this one. So anytime you're working through these problems and you're evaluating, always use your parentheses around the number, even if it's positive. Even if we're doing one like, we'll do the next one, we'll make it positive. We'll do f of 5. Okay, same thing. Everywhere you've got an x, take out the x, replace it with a 5, and then again, everything else goes on the outside of it. Plus 3 times 5 minus 2. Okay, and again, if you don't trust your math on these, go ahead and do what you think first. You've got to do the exponent part first, so it's 5 squared. The negative will then go on the outside of that, so that's a negative 25. 3 times 5 is 15 minus 2. So then it's negative 25 plus 15, which is negative 10 minus 2. That would make it negative 12. Right, again, if you just want to work on your calculator skills just to make sure that you've got them, we'll go back and plug that in. Now, this may be one of those problems where with a positive number, it may not matter. Let's say we left the parentheses off with a positive number. You might actually be okay in this case. Minus 5 minus 2. Yeah, we got negative 12. But with a negative number, because of that extra negative number that's there, you've got to really be careful with negative. So anytime you're plugging in a negative number, put parentheses around it whenever you work through it. With a positive number, just to kind of keep it in the same pattern, I would say do the same thing, because sometimes you get lucky with the positives, you don't need it. But the negative numbers, that's the one that usually, if you don't put the parentheses around the negative numbers, it's usually going to throw your answer off somewhere along the line as you go through those.